some people have asked me when I visit companies, some roundness measuring devices will output the roundness profile in something called undulations per rev, UPR. And then what they do is something called an FFT, and they say, okay, we get this FFT and it's something like this, and on this axis we have undulations per rev, and this we have the height or the amplitude. And then they get something that maybe looks like that. They say, well, what does that actually mean? So let's take this one step at a time. Let's say we got our workpiece, and let's say we have some type of profile on it. Now, if we have a workpiece that looks like that, and let's say we have a perfectly flowery workpiece. It looks like that. And we've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 waves on our workpiece. If we do an FFT, Fourier transform, on that, and it's perfectly sinusoidal, we will get something that looks like that at 8 undulations per rev. Okay? Now, let's say we have a workpiece that looks like this. Still perfectly sinusoidal. I'm not doing a great job drawing perfect sinusoids, but you get the idea. Now, let's say of those perfect sinusoids, there are 30. So now we're going to get a peak at 30 undulations per rev. But now let's say our workpiece is a combination. Let's say our workpiece actually looks like this. So we have a higher frequency at 30 undulations per rev that is sort of transposed over the 8 undulations per rev. Now what we're going to get is 2 peaks. One at 30 and one at 8. But real workpieces don't really look like that. What real workpieces look like is this. Or maybe something like this. A bit messier. So now if we do a Fourier transform on this, our magic little Fourier transform program is going to figure out what these frequencies are, and it's going to say, well, it looks like we've got 1, 2, 3, 4, 5. We've got something around 5. And it's not nice and neat. And then we've got something of higher frequency, maybe something around 30, and we get something like that. And then maybe we have some super high frequency at 150. So we have a peak at 5, at 30, and 150 based on what we have there. With the naked eye, it can be hard to pick these frequencies out. You can try to eyeball it. You can try to figure stuff out. Stick it in the FFT, get your undulations per rev, and then it'll tell you what your dominant frequencies are, which means how many waves or how many undulations do you have around one revolution of your workpiece.